Hello. Last tutorial was about Arnold rendering curves. We have curves in the scene here, like this one, that one, and Arnold does render them. Which of course brings us to the idea, how can we animate the curves? Which goes back to very early stages of computer animation. And I want to show you how you can animate curves in many different ways, really. So let's delete the two curves here. Let's leave the light, the dome light, active, and the polygon plane at the very bottom. And so what we will do now is we just draw a curve with the pencil curve tool, for example. This is how we draw it. We rotate it a little bit so it's not so flat on the surface. And when we click on Arnold here, make render curve, make it a little bit bigger, we get a rendered curve. That's the curve we just drew. Now, in order to animate it, you can do several things. Under modeling here, you have the deform section, and you have lots of deformers. For example, the nonlinear wave deformer. Let's try that. It looks a little bit intimidating, and it doesn't do anything, really. If you move it, for example, up and down, you see the pink color is our curve. It doesn't do anything to the curve, and the reason is that the wave function is set to an amplitude of 0, and we need to increase that. And now you see the pink curve, our curve, moves. Of course, we can set keyframes now, so it starts wobbling around now. But instead you can as well use a sine function. So you just type into the amplitude equals sine and then, well, time. So it will animate in time. Let's pick the curve to see what it does. And that's what it does. It works in the sine realm. Will always repeat and repeat. So that's one way to animate a curve. Of course, you can right click here and go to control vertex and pick several vertices and animate them as well with a deformer, for example, or with ordinary scale and transform tools. I give you an example here. Let's start here at the beginning of the animation. Oh, well, let's start here. Set a keyframe by pressing S. The keyframe for all the CVs is here now. At the end of the animation, I want them in the same position, so I press S again. So I have another keyframe here. And in the middle, I move them, for example, here and a bit lower, and I press S again. So this is what I get now. I have a double animation. The whole curve is manipulated by the sine function, and the CVs in yellow are animated by keyframes now. And of course, you can render it. I'll show you what this animation looks like. Quite nice, really. So let us take this a little bit further. Let's delete the curve and the wave handle here in the outliner. Press delete and lift the surface, the plane, a little bit upwards so we don't see two grids at the same time. This is just for beauty purposes. Of course, you can animate a curve in any style, and especially if you have a special purpose in mind, where you want to make the curve behave like a snake or whatever, you apply certain deformers. In other cases, you might consider dealing with soft body dynamics. And the curve as such cannot be turned into a soft body as far as I know. Actually, I can try it out. Let's draw a curve here. Put it up so we can see it. Then we go to the FX menu, and the soft bodies are under N particles. N particles, soft body. Well, actually, it is a soft body. That's quite nice, really. So what we can do now is add a turbulence field. It will add turbulence to the whole curve, and here you go. Let's do a brief rendering here. Arnold render. It's right here. It's barely visible because it's so small. Here is the soft body, box, which is always covering the particles, and here is the nucleus, which makes the soft body dynamics here. We have an Arnold tab here. We render the curve and make it much bigger and give it instead of a ribbon, a thick shape. And now we render it again, and here's the curve. And the particles are here as well. Of course, we can turn particle rendering off. And you see how under the turbulence field, how the curve develops. And if we spread the animation to 1000 frames, this will be even more interesting because the turbulence field works all the time and doesn't end, so it will keep deforming the curve. If you make the turbulence field stronger, it's currently set to the default setting of 5. If you set the magnitude to 70, for example, it will look differently, of course. Much larger scale deformation and soft body dynamics. But I wanted to show you something else, really. So let's delete the curve, the nucleus, and the turbulent field in the outliner. By the way, if you don't find the outliner, it's this icon here. Very practical, so it's right in the scene. Let's create a surface now, a sphere. Scale it up a little bit and give it a new material. Horrible color, really. And if we want, we can open it a little bit, make Nurbs sphere, and the end sweep or the start sweep, we can change this parameter and it will be sort of a half sphere here. If we would put it to 180, we put it to maybe even less, so it's a little bit more interesting shape. Now with this half sphere selected, we go to N particles again, and now we will choose soft body and the option box. So click here, and that's what we did with a curve before. Make it soft. We press create. Let's not do this for now. Let's instead choose duplicate, make copy soft, and make non-soft a goal. It basically means we're creating a soft copy of this hard shell, and the soft copy will always try to go back to the original shape of the hard shell, so it will be the target. Let's set the weight. That's the amount, how strongly the duplicate, the soft object, goes back to the original. Let's reduce this a little bit and create a new geometry here. Basically, it's a particle system. So we have two things now. One is the particle thing, and one is the original Nurbs surface. And it will guarantee that the new object, the soft body, which is this one, with the little dots around in the cage around it, that it will always sort of remain intact. Now let's create a turbulence field. And the turbulence field now affects, of course, only the soft duplicate. And what happens is this. Basically nothing. So let's increase the turbulence field. Now things start happening, but you see that the soft shell always wants to go back to its hard origin. That's the weight we just introduced, how strongly the goal should be reached. So you need a strong, an immensely strong turbulence field in order to make the turbulence effect visible at all. Let's go to 1000. So the deformation gets bigger now, but it always, the soft body tries to go back to the original shape. So if we animate the magnitude, for example, let's put it to 1000 at the very beginning of the timeline. Here's a keyframe. And then let's maybe reduce it to 400 somewhere here, and reduce it to a very small number like 15 here. So that's the animation we get then. It starts with a very strong turbulence field. Now it gets a little bit more moderate. And now the effect will slowly decrease. So what we want to do now is create a curve. This is the soft body. We can create curves which depend on the actual shape of the soft body. So if we do it here, it will create curves which stay always in the same place because that's our original, but that's the one we want to create curves from, which will look animated then. In order to do that, we pick the object, which is basically a copy of Nurbs' sphere, that's the soft body, and we go to modeling because it's about curves now. And here we are back at the curves menu, and under the curves menu we have the quite delicate command duplicate surface curves. And when I click it now, look at what happens in the outliner. We have duplicated curves here, and in order to make them renderable, we'll have to put them together in a box, and it's under the Arnold menu. That's the box now. It's basically a group here, a special Arnold group. And here we see it should be thick, and the width should be quite big. And now let's do a render. So what we see here now is the original shape. That's the so-called, so to say, hard shell we started off from. That's the goal where this thing, that's the soft body, always tries to go back to that shape. And here we have only the curves, pretty thick now, and they're penetrating the original. And now the neat thing would be to make all the rest invisible. And the most elegant way to do that is pick the object, that's the original curve, for example, and go to the Arnold tab and turn off its primary visibility. And you do the same with the copy of the Nurbs sphere. Turn off the primary visibility, and if you want, you can also turn the particles off. Where are they? They are here. They have an Arnold tab too, I think. Yes, here. And here it's the same. The primary visibility, that's what you don't want to render. You don't want them to cast shadows, for example. We need to turn that off as well for the other objects. I forgot that. So no shadows, please. And where is this is the object, no shadows. I think now we're all set, and we do a re-render now. This is what we get. And of course we can render an animation now, and if you want to do that, render the animation of this thing, I would recommend to delete a few curves so it looks a little bit more interesting. We can hide those two, and for example delete just randomly, just delete them. So we have those curves working now. And then we go to the rendering preferences. We need to give it a name so we find it later. I call it wobbling curve B, for example. And I render JPEG because this is only for preview reasons. The quality is 100. That doesn't matter really. It doesn't make a big difference. Most importantly is name and extension instead of name and single framed. So it's going to be a name, that's the name, plus a number, that's the number of the frame here, and the extension, which is going to be JPEG. Frame padding means if you render over 1,000 frames, you need a good padding in order to get 0001 for the first frame, 0100 for the 100th, etc. And here is the start frame and the end frame. Let's set it to maybe 500. And then we close this thing, and then we go to the rendering menu, go to render, and invoke batch render. Batch render means we're rendering all the things in the scene now. We're rendering the perspective window currently. That's that window here. If we want to see more, we can adjust the view, for example, now like this. And we go to batch render, and it will tell us this is a student version, but still, let's continue. And the rendering starts down here. It tells us it is starting. And in a second it will start rendering the first frame in that sequence. Now it's rendering the first frame here. And now the second frame, so it's going very fast because the curve is not very much of a rendering job to do. But it's not trivial either. So I appreciate the rendering of curves, which I hadn't seen before really. So a couple of minutes later, we'll call up fcheck. It's a tiny program which has been around Maya since its beginning and even before, I think. And it's a very fast tool which allows us to play back animations or show us single images. You just go to open animation and select the first file in the row, and then the animation will cache first, and once it's cached it will run fluently like here. I hope that was inspiration enough. Now put your own creativity to work. So that's it about rendering curves, and rendering curves using soft body dynamics.